This video will help you with the questions on homework number 11. So let's take a look at the first box. The directions state to graph both equations on the same grid. Find the point where they intersect, also known as the solution. So this is actually a new topic for you, but the skill is something you already know how to do. This is a linear equation. Its graph is a straight line, and it has a constant rate of change. This linear equation is also written in what we call slope-intercept form. Slope-intercept form is where the y is isolated and the x and the constant value are on the other side of the equation. When it's written in slope-intercept form, the coefficient of x is the slope and the constant is the y-intercept. So we're going to use that knowledge to help us graph this first equation here. I'm going to highlight it in red, and I'm also going to draw it in red. A y-intercept is the point in which the line crosses the y-axis. So my y-intercept is positive 7. So I'm going to go to my y-axis here, and I'm going to draw a point at positive 7. That is my initial value. Now I'm going to use the coefficient of x, the 3 here, which is my slope, or also known as my rate of change, right? My rate of change is how my point rises and runs. So if you have a whole number, you'll need to turn that into a ratio. Don't forget the numerator is the rise, or the change in the y value, and the denominator is the run, or the change in the left and right x value. So from my initial value of 7, I'm going to create more points along this line. So from 7, I'm going to move in this direction. I'm going to rise 3 along the y-axis and run 1 along the x-axis. Now I can't draw any more points because I've run out of grid space. So I'm going to take this fraction, 3 over 1, and I'm going to write an equivalent version, which is negative 3 over negative 1. They both have the same value, but by changing both of the signs of the numerator and denominator, I'm able to create more points on my grid. So now instead of rising positive 3 along the y, I'm going to move negative 3 along the y, and I'm also going to move negative 1 along the x. A change of down 3 on the y, a change of left 1 on the x. So I don't draw my point until after I've done both of these moves. Change of 3 on the y, change of 1 on the x. Negative 3, negative 1. Rise negative 3, run negative 1. Now if you have a ruler, you'll want to take it out now, and you'll want to make sure that your ruler lines up all of the points just like this. Now because we're going to be drawing another line on this grid, we need to label this red line with its name. We need to label this red line with its name, which is y equals 3x plus 7. I'm going to write it over here. Y equals 3x plus 7. I'm not going to write it like this on the graph. That takes up lots of drawing space, right? What if I want to draw my next line there? I'm going to label it up and off to the side. And my second linear equation is y equals x plus 1. Again, using my slope and y-intercept, I'm going to use a shortcut to graph this. I'm going to start at my initial value of positive 1. And my slope, which I can't see, is 1 over 1. So rise 1, run 1. Up 1, over 1. Right? Up positive 1, right positive 1. Change in y, change in x. Change in y, change in x. So 1 on the y, 1 on the x. Now again, don't forget, you can reverse the signs here of both your numerator and denominator, and you can draw points on the lower half of the line. So down 1, left 1. Negative 1 on the y, negative 1 on the x. Negative 1 on the y, negative 1 on the x. Do you see what just happened there? My blue point overlapped an existing red point. So that is an intersection point. So that point right there is going to be the name of the point we write for our intersection. Let me continue drawing the rest of the points along this blue line. Then I'm going to use a ruler, right? And you're going to connect each of these points precisely with arrows on both ends and a label on the side. And now I'm going to name that point in which they overlapped, right? Which was right here. That point which they overlapped is -3, -2. And that is how you graph a system of equations, or two equations on one grid. Now let's do the same for question 2. Start at your y-intercept, +5. Use your rate of change, right? Use your slope number, -3. Make it a ratio. So the 3 is negative, the 1 is not. So I'm going to go -3 on the y, +1 on the x. Down 3 over 1. Down 3 over 1. Down 3 over 1. -3, +1. And don't forget, you can reverse that. You can turn this into a +3 if you turn the denominator into a -1. So that would look like this. +3 on the y, -1 on the x. +3 on the y, -1 on the x. So that's off the grid. So I'm simply going to connect these points here, draw my arrows, right? Go all the way off the grid, please. And then write your label up here. -3x + 5. Great, now I'm ready to draw my second line. I'm going to use blue here, right? Blue for this line here. And it has the same y-intercept. So you know what that means. We've already found our intersection. But I'm going to use this rate of change to draw more points and complete my line first. So from here, I rise 1, run 3. Rise 1, run 3. Rise 1, run 3. And don't forget I can reverse that. I can reverse the signs of both the numerator and the denominator. Down 1, left 3. Down 1, left 3. Use your ruler to draw a nice straight line, complete your arrows, and don't forget your label. Now I have to answer my final question, which is what is the point of intersection? So that was right here on the y-axis at the y-intercept, which is 0, 5. Alright, the last one here is a little tricky sometimes for students because you can see the slope value, but you don't see a y-intercept. So when your y-intercept is missing, the only invisible number you can have as a constant is 0. So that means my y-intercept is 0. My rate of change is 2 over 1. So up 2 over 1. Up 2 over 1. +2, +1. And don't forget, you can reverse it. -2 over -1. So down 2, left 1. Down 2, left 1. So after I draw as many points as I can fit, I use my ruler to make a nice straight line. I draw my arrows off the grid, and I label my equation, y equals 2x. Now you don't have to write that 0. Remember, it can be left invisible. Now let's do our second line here in blue. +10 is the y-intercept, and -3 over 1. So down 3 over 1. -3, +1. You saw that? That was an overlapping point, so that is our point of intersection. So I'm going to draw as many points as I can fit so that my line is nice and long and accurate. Whoops, see, that one wasn't so great. I'm going to try drawing that line again. I need a ruler to make sure my line is straight and goes through all of these points. So y equals -3x + 10. Now don't forget to write your point of intersection. That point where they overlapped was 2, 4. That point is a solution to both of these equations. So if I put a 2 into the x value, and I put a 4 into this y value, then this would be a true sentence, right? 2 times 2 is 4, and y is 4. Now I do the same for the second equation. If I substitute a 2 here, I would get -6. -6 + 10 is 4. And if I put a 4 in here, 4 would be equal to 4. Alright, let's take a look at the second box. Find the solution to the equation shown. So this is what we call a single variable equation, and we're going to use some properties of equality to bring our x's on the same side of the equal sign. We use our additive inverses to create a cancellation. I'm going to do the same thing here in the next step. This time I'm going to use the constant. And my last step, the division property of equality. X is equal to -1. Question number 5 requires you to do some distributing. I'm going to start here with 2 times x, and then 2 times 3. But I do not multiply it by the rest of the sentence. Now notice the difference here on question number 5. In question number 5, the x's are on the same side of the equal sign. So I don't use an inverse. I simply combine like terms. 2x's minus 7x's is negative 5x. Rewrite the rest of your problem. Use an additive inverse here. Remove the constant from the left side. And then use a multiplicative inverse here to isolate my variable. Final answer, negative 3/5. Leave it in fraction form. Now for question number 6, I have variables on both sides, but this side has only one term. So I should never be using this piece for my inverse. I'm going to add 4x to both sides. And that gives me 6x equals 12. Divide both sides by 6. Alright, let's take a look at the bottom half here. In the bottom half, we're talking about whether an equation is linear or nonlinear. There are a few rules you need to know. One is, no powers other than -1. No powers, right? Positive 1 is acceptable, but -1 is not. 2 is not. A square root is not. An absolute value sign is not. So no powers other than positive 1. No products of variables. No products of variables. So products of variables would be something that looks like this. 3 is equal to x times y. That's a product of variables. So you can't have that. And then the last is no variables in the denominator. And that is actually a repetition of the first rule. Because if you have a variable in the denominator like this, technically that x has a power of -1. It really means this. And we'll learn that later on this year. So again, no powers other than -1, no products of variables, and no variables in the denominator. If you have any of those things, you are nonlinear. So let's check our questions here. Number 7. All the powers are 1, no products of variables, no variables in the denominator. That is linear. Second question. All variables have powers of 1, no products of variables, no variables in the denominator. Question number 8. Our variables, this one has a power other than 1. So that is non-linear. Now let's take a close look at this second one. Look at your variables. Do they have any powers? No. So they're invisible ones. Are there any products of variables? No, they're adding each other. Are there any variables in the denominator? Nope. There's a 3 in the denominator, but not a variable. So this one is actually linear. Number 9 doesn't break any rules either. But this one, that breaks a rule. Can't have a power other than invisible 1. This one does not break any rules. This one, it breaks the variable in the denominator rule, so it is nonlinear. How about this one? I quickly quickly mentioned it at the beginning, but this is not allowed. Absolute values of x's are not linear functions, and square roots of x's are not linear functions. Actually, the square root of x, you'll come to find, has a power of 1/2, technically. So this is nonlinear, because it breaks the power rule. Alright, let's take a look at the Wednesday box. Graph the linear equations shown in the table on the coordinate grid provided. So I'm going to take all of these points and put them on that grid. So remember, a data table is a bunch of ordered pairs. So -3, +5. There's a point. 0, 3. 3, 1. 6, -1. And you'll notice all of my points are nicely aligned to create this linear function. So let me use a ruler here and connect these points. Very good. Now the task down here says write the equation of the line shown in the table and on the graph. Well, if you did not have this fancy graph, if you did not have this, then you would have to use your point-slope formula, right? You'd have to use your fancy point-slope formula to find all of these missing parts. But if you have a graph, you can find your slope-intercept form very quickly if you know these two values. If you know the slope and you know the y-intercept. Well, this is the y-intercept. And this is the slope. Right? So we can write this equation very quickly. The slope is down 2, run 3. So there's our slope. And the y-intercept is +3 right there. And that's all we have to do. So let me clear this away so you can see that, right? So our slope is down 2/3, and our y-intercept is +3. Alright, let's take a look at this last section here. Number 12, find the rate of change for the following data. Remember, rate of change is the change in y over the change in x. You can also use, right, the fancy letters of this formula. The y's from both points, the x's from both points. So I'm going to set up my fraction with my minus in the middle, and then I'm going to put my y coordinates in first. And then I'm going to put my x coordinates in second. Use the calculator here. Don't forget, when you have two minuses in a row, it makes a big positive. So -12 plus 8 is -4, and 8 minus 6 is 2. So the rate of change is -2. Number 13, identify the rate of change in the following linear equation. So I'm looking for the coefficient of x. Not x, but the coefficient of x. So I just write 5. Number 14, which of the following is not a linear equation? Right, remember those 3 rules? Only powers of 1, no products of variables, no variables in the denominator. So looking at our choices here, letter C breaks the power rule. So letter C is not a linear equation. Number 15, which of the following graphs is a linear equation? To be linear means you look like a line. And that's D. And that concludes the tutorial for homework number 11. Good luck on yours.